Now that we've done a little bit on the background of correlation and kind of what to look for on scatter plots and that R value, I'm going to tell you how to find the R value. Now, the easiest way to find the correlation coefficient in the equation of the regression line is to definitely use a graphing or statistical calculator. Graphing calculators have statistical menus that actually allow you to enter X and Y data. They let you to graph scatter plots. They even let you find that R value and will compute it for you very, very quickly. So normally this is something that we would do using technology. We can do it by hand though. So we're going to do it by hand because you guys are not required to have, a statistical calculator for this course, as we're only doing one little section here. So we'll just do one example to show you how you can find this R value by hand. But do understand that in the real world, it's usually done with technology because it's quite complicated, especially if you have a large data set. You don't want to be doing this formula by hand. So this is the formula that you have to use to find R when you do it by hand. You can see it's quite tedious. So don't forget as well that this symbol right here, that sigma, does mean to sum or to add. So although there's a lot of it there, a lot of this is addition. So n here is the number of your data points. Sigma x means the sum of all x values. Sigma y means the sum of all y values. Sigma xy means that you would multiply the x and the y first and then add that all up. Sigma x squared means that you would find x squared first, then add those all up. Same thing with sigma y squared. You find the y squared first, then add those all up. These two are different. These two, you find the sum of the x's first and then square, or the sum of the y's first and then square. So again, I just kind of want to add some parentheses in there. I think it makes it a little bit easier to see the order in which you do things. So we're going to do this by hand for one example using that same data set that we've been working for. And I'm going to show you just how to stay organized to find these by hand. You have a couple of these on the homework, but not too many. So shown below again is that same data set involving the number of years of school completed by 10 randomly selected people and their scores on the prejudice test. Recall that the higher score on a prejudice test indicates greater levels of prejudice, and we are going to determine the correlation coefficient, which is that R, between the years of education and the scores on a prejudice test. Now, our years of education is X, and our score represents the Y's. So I'm going to help you here. So this is the easiest way to stay organized first, is we're going to list the X's and we're going to list the Y's. So my X values are 12, 5, 14, 13, 8, 10, 16, 11, 12, and 4. And I'm actually just going to make a little table because I think it'll be easier to keep track. This is something where if you had lined paper, it'd probably be easier. And then I'm going to list the Y. So I have 1, 7, let's see, 2, 3, 5, 4, 1, 2, 3, and 10. Now, if you look back at that formula, there's quite a lot of parts here. So notice that I have to sum the X's, I have to sum the Y's. I also have to multiply the X's and Y's and get the X squared and the Y squared values too. So I'm going to find all that stuff first, then I'm going to sum everything afterwards. So I'm also going to do a column for X times Y. So again, this is multiplication here. So 12 times 1 is 12. 5 times 7 is 35. 14 times 2 is going to be 28. 13 times 3 is going to be 39. 8 times 5 is 40. 10 times 4 is also 40. 16 times 1 is 16. 11 times 2 is 22. 12 times 3 is 36. And 4 times 10 is 40. I'm also going to calculate my X squareds. So I'm going to square all these values. 12 squared is 144. 5 squared is 25. 14 squared, this one I did not know off the top of my head. I did it out. It's 196. 13 squared is 169. 8 squared is 64. 10 squared is 100. 16 squared is 256. So your calculator can help you with these. 11 squared is 121. 12 squared is 144. and 4 squared is going to be 16. So remember, when you're squaring, you're just taking that same number times itself. So 12 times 12, 5 times 5, 14 times 14, and so on. And finally, I'm going to do those y's. So 1 times 1 is 1, 7 times 7 is 49, 2 times 2 is 4, 3 times 3 is 9, 5 squared is 25, 4 squared is 16, 1 squared is 1, 2 squared is 4, 3 squared is 9, and 10 squared is 1. Now I'm going to add up all the columns as well. So I'm going to go right down the columns. Use your calculator here. I already did it to save us some time. We're going to add those all up. So 12 plus 5 plus 14 plus 13 plus 8 plus 10 plus 16 plus 11 plus 12 plus 4. And what you get here is going to be 105. For the next column, you're going to get 38. Then you're going to get 308. Then you're going to get 1,235, and then you're going to get 218. So these are all some of the key features that we need. Now, what do all these mean? Well, the sum here is the sum of the x's, right? This is the sum of all the y's. This is the sum of all the xy's. This is the sum of all the x squareds. And this is the sum of all the y squareds. And our formula, I'm going to rewrite it at the bottom here, was n times the sum of xy minus the sum of the x's times the sum of the y's all over. And we have a square root there. So it's n times the sum of the x squareds minus, oh, sorry, I have two roots there, sorry. The sum of the x squared, sorry, and then this is a second root. So times, and here's a second root. And the sum of the y squareds minus the sum of the y squareds. Oh my goodness, this is a long formula. So I'm just taking this formula from the page before, and you can see it's written much nicer over here. So just to clarify on the bottom, sorry, I made one giant line by accident, but you have one square root here, and then you're multiplying it with a second square root here. Okay, so I'll make that really clear when I rewrite it now. All right, so let's fill in all of our values. Now our n here is 10 because you have 10 data points. Or data pairs, I guess, right? 10 people. So we're going to have 10. And that's going to be times the sum of the xy's, which is 308, minus the sum of the x's, which is 105, times the sum of the y's, which is 38. Okay. Again, I have 10 times the sum of the x squareds is 1235 minus the sum of the x's, which is 105, and then we're going to square that value. Now my second root, 10 again, times the sum of the y squared, which is 218, minus the sum of the y's, which is 38, squared. So this formula is not difficult, but it is extremely, extremely tedious. So you can see why we would normally do this with technology, right? And also why you'll only have a few of them on the homework, because they do take a really long time to do out. So let's keep going here. If I simplify my numerator, then I've already done my calculator work here. I'm going to get 10 times 308, and then I'm going to do minus 105 times 38. And what I'm going to get here in my numerator is negative 910. 10. Now, in my denominator for the next group, let me show you this one for a second. Okay. So again, for my numerator, if you want to see it, I just did 10 times 308 minus 105 times 38. And I got that negative 910. Now for my denominator, I'm going to just break it in parts here. So inside the root, I have 10 times 1235 minus, and then 105 is being squared. So 105 squared. So for the first square root, I'm getting the square root of 1325. And then for the second square root, I have, let's see, 10 times 218 minus, and that's going to be 38 squared. And I get 736. Now, if you can't do this all at once, you can always do the 105 squared out first, right? And then you can kind of break it into pieces, do 10 times 1235, and then minus that 11,025. So again, you can break it into pieces if you have to make it easier. So the hardest thing here is all that calculator work. Now, you're definitely going to have to do some rounding here. So I'm going to just clean up my denominator for a second. I have the square root of 1325 times the square root of 736. Keep in mind these are separate square roots, so it's not all one big square root. I hit enter, and you're going to get a really large number here. So I'm going to do the negative 910 on top, and then I'm going to divide it by that whole number. I'm going to use all the decimal places, and I get about negative 0.92 here is what your book uses. And they round to 2 decimal places. Okay, so a lot of work to find this by hand, again, which is why we tend to use technology for this sort of calculation here. Now, what we see though is I see my R value is about negative 0.92. This is a very strong negative correlation, right? Because it only goes between -1 and +1. This is very close to -1. So this is very strong negative correlation here, which is really what I saw in that graph, right? We saw that decreasing, those decreasing points in that first initial scatter plot. So my R here is kind of helping to say, like, hey, your observation, Professor Paula, was correct. The graph looked like it was decreasing. It looked like a pretty straight line, but now my R is kind of just helping me more to say, yep, that really does look like a strong negative correlation there. So that's how we can find our R value by hand. You definitely want to do each of these columns first, and then I would carefully rewrite that formula and just plug things in and take it little steps at a time when simplifying, because that's where students tend to make mistakes.